Alright guys, we are going to talk today about what geometric probability is. And you've probably seen lots of probability before in Algebra 1 or just kind of in random daily life. You kind of know what probability is. It's like the probability of rolling a dice and it landing on a 1 is going to be 1 out of 6 because basically the definition of probability is, probability, my handwriting's bad on this by the way, is equal to favorable outcomes over total outcomes. Total. Come on. There you go. Total. Favorable over total. Okay, that's what we need to know. Write that down. Okay, so in geometry then, it's going to be, we're going to talk about length and we're going to talk about area in terms of probability. So let's first talk about length. And let's find the probability that a random point on AB is also on CD. So our total points here are the ones that are on AB. Not total in this diagram, but the ones that are on AB. In terms of how long AB is, there's 23 units on AB. Okay, and then see, I've counted that. So, and then on CD, right, that's our favorable. We want to find the probability of a random point on AB also being on CD. So favorable is CD. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is 12 units of length in CD. So the probability here would be 12 out of 23. Okay, favorable over total. Okay, so now let's talk about probability as it relates to area. If we want like a randomly thrown dart, if we know it's going to land at least in J, let's find the probability that it landing in J but not in M. And once again, probability is favorable over total. So our favorable region is going to be trapezoid J, okay, minus the triangle M, okay, all over J. Okay, total area here is the entire trapezoid, even including M. Okay, but we know that the favorable area does not include M, so we're going to take the trapezoid's area and subtract the triangle's area, and it's going to be all over the trapezoid's area, J. Okay, so that's how we would calculate area favorable. Okay, we want to kind of think about how we get the area of our region that we want, and it's always over the total area of the region that we're looking at. Alright, so last one on this slide here, let's find the probability that a point chosen on RU is also on TS. So it's just a little bit different here, but we know that our total area here, or our total length here is going to be RU, because we know that, okay, starting with all the points that are on RU, how many are on TS? Well, there is, obviously there's an infinite amount of points, but RU is 7 units long, okay, 0 to 7. Okay, and then that are also on TS, well, I understand TS is 5 units long, but these points right here are not on RU as well. Only the points from T to U are on RU, so those are our favorable points. So the favorable length here is 2. So the probability that a point chosen on RU is also on TS is 2 out of 7. Not too tough. Okay, so let's find the probability that a randomly thrown dart here, which we know is going to land somewhere in the big circle, is going to land in the yellow. Okay, so let's start with this notation down here. This notation is used a lot. This means probability of yellow area. So sometimes P and then parentheses, whatever we're looking at. So it just shortens up so we don't have to write the probability of landing in the yellow every single time. Okay, so that's what we denote that as. Okay, so probability of yellow is going to again be favorable area over total area. Oops, what's this? Over total. Okay, which, let's find the favorable area here. We kind of did this yesterday a little bit. Okay, and we can take the second circle in here and subtract the inner circle to find just our favorable area, right? This would just give us the area of the yellow, which is good. So that is 81 pi, okay, radius of 9, square it, 81 pi minus 9 pi is favorable area. Okay, and then total area of everything here, including blue, including yellow, including red, is what we want here, which is fairly easy to think about. That's just 9 radius of 13, so 169 pi. Okay, so 81 minus 9 is 72 pi over 169 pi. Okay, the pi's cancel out and we're left with 72 over 169. Now 72 over 169 does not reduce as a fraction, so we can leave it like this. You could write it as a decimal. As a decimal, that would be, let's see, 72 divided by 169 is 0.42, aka you got a 42.6% chance. Okay, 0.426 here, a 42.6% chance. If you randomly threw a dart and you knew it was going to at least land inside these confines, you have a 42% chance of getting in the yellow. Okay, so that's what we're calculating here. Favorable over total, look at how I did that, and let's move on. Okay, one more probability as it relates to area here before we move on to one last problem. And this one is talking about the probability of landing inside this circle but outside the pentagon. So a little bit tougher here, but let's again set up the fact that we want favorable area over total area. Okay, favorable over total. Okay, so let's calculate favorable area. Just as a plan right now, favorable is circle minus pentagon. Let's go circle, come on, minus, there we go, pentagon. And total area is just circle. Okay, so how are we going to do this? Well, we learned yesterday how to find the area of a regular polygon when we're given a radius. It's a little bit tougher. But first, let's just find the area of the circle. Okay, the circle has an area. Let's do that down here. Circle has an area of 25 pi. That's easy. 5 pi squared. Okay, the area of the pentagon, okay, is 1/2 times the apothem times the perimeter. And actually, that should be lowercase a, I guess. Lowercase a is how we denoted apothem. Okay, so let's go ahead and take out a little chunk of, all right, that. Let's go ahead and take out this right triangle that we did yesterday. We know it has a hypotenuse of 5. And we also know what that angle is. It's half the central angle of a pentagon. And a central angle of a pentagon is 72 degrees, right? That's 360 divided by 5. But then we need to divide that by 2. So the angle here is going to be 36 degrees. We want the apothem. And we want this side because that's going to get us to the perimeter of the entire figure. We'll call that x. So let's first say that the, the opposite over hypotenuse would give us x. So the sine of 36 equals x over 5. All right, and then also the cosine of 36 equals a over 5. And from this we can find the apothem and we can get to the perimeter after we have our x value. So let's first find the apothem, I guess. Let's go cosine of 36, okay, times 5. And so the apothem ends up being 4.05. Okay, and that's rounded to the nearest hundredth, which is fine. Let's round intermediate values to the nearest hundredth because we're going to need to do a whole lot of calculating here. We may not be able to save all of these numbers. You can write them all out if you want to, but otherwise let's round intermediate values to the nearest hundredth. Okay, now for this side of that right triangle, our x value, we want the sine of 36, okay, times 5, and that gives us 2.94. Okay, so x equals 2.94. Now that's not the perimeter, that's not even close to the perimeter, but we do know that this chunk represents 1/10 of the perimeter, right? Because it's half this side. Okay, so then we'd be at 1/5. So we basically want to take that value, let's leave that in our calculator here. Let's just multiply it by 10, and the perimeter, right? The perimeter of the pentagon, P, is 29.39. Okay, units. All right, so now that we have all that, we can find what this probability is. Let's go back over here. It's circle minus pentagon all over circle. So that's 25 pi minus the area of the pentagon was 1/2. I'll just do 0.5. times 4.05 times 29.39. Okay, so circle minus pentagon gives us an area of 19.03 units. That's what you should, units squared, I should say. Units squared. Okay, so now that we have that, all right, and that's rounded, but I'm going to leave that in my calculator, this value. It's 19.025, blah, 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 blah. And then we just want to divide that by the area of the circle, which is 25 pi. So answer divided by, in parentheses, 25 pi. Okay, and so we get, all right, when we do that, we get a decimal here, and that ends up being 0.242. So let's just go 0.24. So 24%. So you have a 24% chance of landing. That's actually a little more than it looks. It looks like it'd be a little less than that, but that's correct. Everything we did was correct. We had a good plan. We executed it correctly. So that's that. All right, last slide here. I'll go quick. I want you to pause the video and read this, read this word problem. But I'm going to kind of keep rolling here. So here's what we want to do. We want to draw a number line, okay? And actually, it's more of a timeline. Okay, I arrive at the bus stop at 2:48. Okay, I need to be picked up by 2:52. So let's go ahead and do that. If I'm not picked up by 2:52, okay, I'm going to not make it in time. Okay, now 3 p.m. is when we want to get, when I want to get to the airport. So now let's talk about one more thing I'm going to add on to this timeline that's going to help us out. Okay, let's assume worst case scenario that I arrive at the shuttle stop, right after the previous bus left. Okay, so worst case scenario, this bus is going to come at 2:58. All right, so about 2:58. 10 minutes from when I arrived. If I completely missed the last one just by a hair, then I have to wait 10 more minutes. So I know that I'm looking at this possible time frame of being picked up. So really 3 p.m. doesn't really matter right now. We want to look at this length, 2:48 to 2:58 is the total length that I'm looking at, and the probability that I am going to make it on time is if this bus comes in between this length, right? If it comes in between 2:48 and 2:52, I'm set. If not, I'm going to be late to my flight and obviously not going to be very happy. So the favorable over total here is 4 minutes over 10 minutes, which is 2/5. Okay, look, you'll see one of these on quiz or test, so look at this, look how to do it, make a number line. All right, we'll talk about it in class as well. All right, that's our video. It's the first one, went a little long. I'll try to shorten them up from now on. All right, later. Have fun. Bye.